Hello everyone, welcome to this session. Today we are going to start with strength of material, Unit 1, the introduction to the engineering mechanics. Okay, so this is a new subject today I am going to start with. Okay, that is strength of materials. So, as you know, the first unit, that is the introduction to the engineering mechanics. Okay, what is engineering mechanics? It is a branch of engineering which deals with the uh, force and the analysis of the forces exerted, okay, on the body. Okay, these forces are external forces which are applied. We are not studying the internal forces, we are studying the external forces applied over the object or the body. Okay, that is called uh, engineering mechanics. Okay, we'll start with the actual concepts. Okay, so first thing we have to understand is what is force. Okay, force is nothing but the external load applied on a body, okay, is called as force. If you consider any body, okay, for which you apply a push or a pull, okay, that is called as force in a normal language. Okay, you can say it as force. Okay, we apply force in every object. Okay, picking a pen or pencil, from pushing a door, all to smallest of the smallest things, we apply the force. Okay, what is the SI unit of the force is Newton. We denote it in the uh, we denote it by N. Okay, and force is a vector quantity. Okay, vector quantity means the unit which has both magnitude and direction. Magnitude means its quantity. If the force is applied, how much quantity we apply the force, that quantity is called as magnitude. If I apply 100 kilonewton or 100 newton load or 1000 newton load, that 1000 newton which we apply is called as magnitude. Okay, if we say if the car is moving with a speed of 100 kilometers per hour, okay, 100 kilometers per hour is the magnitude. Okay, direction means in which direction it is moving, it shows the direction. That direction is also considered in the vector. Okay, so vector quantity means which has both magnitude as well as the direction. Okay, next, coming to the characteristics of the forces. As I said, magnitude, the length of the vector represents the magnitude of the forces. Okay, direction, second one, direction of the forces can be represented by the arrowhead. Okay, in which direction the forces will be applied can be shown by the arrowhead. Okay, next is the line of action, the line in which the force is applied. Okay, or the force will be is going to be acted, that is called as line of action. Okay, a point of application, it is a point at which the force is to be applied. At certain point the force is applied. You are going to push a object, the line of direction is forward, but the application will be where, on that surface of that object, that point where we apply the pressure or apply the force or the load, that is called as point of application. Okay, next, characteristics of forces. This is what a force, where F is a magnitude, okay, and the arrowhead shows that the direction of the force, in that direction the force is being applied. Okay, next, what we want to know is line of action. What is line of action? As we said, in the direction in which the force is going to be applied, okay, that is called as line of action, right? So you can see this. right? In the direction previously, okay, backward or forward, it might be, but the line in which the force is going to be acting, that is called as the uh, line of action. Okay, it can't be to the sides. Okay, the force is acting, or the action of line is in the direction of the arrowhead. In which direction the force is being applied, in that direction will be the line of action. It can't be like this, or it can't be like this, because the line of action will be in the same line in which the direction of the force has been applied. Okay, that is a thing what a line of action means. Okay, next, there are various system of forces. Okay, there are various system of forces. Okay, mostly two. We divided the system of forces. System of forces is nothing but when two or more forces are been applied over a body. Okay, that that is called as system of forces, where number of forces together are applied over an object. That whole um, scenario is called a system, or the whole object, or the whole phenomena is called the system over which the force is been applied. Okay, you can say it is divided into two parts, that is coplanar force system and non coplanar systems. Okay, what is coplanar? Coplanar is nothing but the force which lies on a same plane. Okay, the force which lies on the same plane is called as coplanar. Okay, if you can see any plane, it might be a horizontal plane, it might be a vertical plane, in whichever plane the forces are been acting. Okay, these forces are called coplanar forces because these are in the one same plane. If the forces are applied in like these directions, okay, means are not in the same plane, right? This is in the vertical plane, right? This is in vertical plane, and these are in the horizontal plane, right? So these are called as non-coplanar because they are not in the same plane. They are called as non-coplanar. Okay, this is the difference. Then in the coplanar also there are different types. Okay, now collinear. Collinear means the forces lies in the coplanar, and collinear means they lie in the same plane and also they lie in the same line. Okay, the line of action is the same. Means what? All the forces are acting in the one line. As we said, the line of action, right? Same way, all the forces are in the one line. In this way, I can show you. If the force is applied in the direction, then another force will be applied in the same direction, in the same line. Okay, it might be in different directions. Okay, but they are in the same line. Okay, understanding? These are their forces. Okay, F3 and F4. Okay, this is collinear. Next is coplanar and co-current forces. These forces lie in the same plane, but they start from a single point and they spread or they radiate in different directions. I will show you the example here. If the forces lies in the same plane and meet at the same point but act in the different directions, they are called as co-current coplanar forces. We assume that they are in the same plane, right? What they are merging, or they are coming from the single point and they are radiating in the different directions. Okay, they are acting in the different directions, so it is called as co-current forces. These are the basic things you have to understand. Okay, next is non co-current and non-parallel forces. The line of action are in the same plane, but they are neither parallel or nor meet at the same point. Hence, they are coplanar, non-concurrent, and non-parallel forces. What is this non-parallel and parallel forces? Okay, we'll try to understand that first. Then we'll go to the definition. Parallel forces are nothing but the forces. Direction of the forces are same. Okay, those forces are called as parallel forces. If this is the direction of the force, okay, these are called as parallel forces. Okay, these are called as parallel forces, not non-parallel forces. Another type of the forces are unlike forces. Okay, unlike forces, that is, the forces might be in different directions, opposite directions. So those forces are called unlike forces. Okay, coplanar force of systems. If two or more forces acting in a different plane, sorry, there is a mistake. It is a non-coplanar. It is non-coplanar. Okay, the typing mistake is there. Okay, they act in a different planes. This might be your horizontal plane, this might be your vertical plane. So the forces act in the different planes. Okay, they are not in the same planes. So these type of forces are called, okay, non-coplanar forces of systems. Okay, now what is principle of transmissibility? Okay, it is nothing but we have understood the main concept of this is line of action of forces, right? The force applied on any object are in the same line in the direction of the force. Means the force will be transferred from one point to the another point in that direction only, right? If we are applying a force, the direction of the application or transfer of the application of the forces will occur in the same direction of that of the line of action. That is a saying in the principle of transmissibility. It is saying that the force which are applying in a direction, okay, in the line of action also, okay, in that same direction only or in that same line of action only we can transfer the load from one point to the another point. If you consider this is an object, okay, we are applying a force like this, its line of action is like this, right? So same way the transfer of the force F from the this point or application to here, right? We are transferring the load force from this point to this point, right? Right, we are transferring the load from this point to this point of the object by applying the pressure. It is moving forward but the pressure is transferred, so that transfer of the forces act will be along that line of action only. It can't vary. Okay, that is a principle. Okay, the principle states that the force can be transmitted from one point to another point along the same line of action such that the effect produced by the forces on the body will remain unchanged. Okay, it is the same saying what I have explained. Next is equilibrium of forces. What is equilibrium of forces? We'll first understand. Okay, when a stationary body or any body which is in rest, okay, we apply a external force over it. and once we apply the force over it, the body doesn't move, it remains into the rest. Okay. Actually, when we apply a force on any object more than the load of that weight of that object, it will move, right? In the case if we apply the force and the body doesn't move, that means the body is in the equilibrium condition. Okay. If this is the object, okay, and we apply the force here like this object will remain in rest or remain in its position, right? So it is said that the body is in the equilibrium condition, right? Okay, we understood what is equilibrium of forces. When we apply external force and the body remains in the state of rest under the action of forces, or when we apply the force, it is said to be in equilibrium. Okay, so we understood what is equilibrium, right? Now we will understand how we can gain or how we can produce the equilibrium conditions when these equilibrium conditions occur. Okay, how this equilibrium conditions occurs, or we can make it bring the object into equilibrium conditions, we'll understand. Okay, this is the difference between the equilibrium of forces and the principle of equilibrium. This is a difference. We in the equilibrium of forces we understood what is equilibrium. Okay, now we are trying to understand what are the different equilibrium, how the equilibrium conditions can be satisfied. Okay, whenever a stationary body is subjected to the external loads, okay, if the algebraic sum of the all the external forces as well as the moment, okay, of all the external forces about any point in their plane is 0. So what it is saying is, if there is an object or a body, okay, and we apply the force or a moment is nothing but a rotation. Okay, we apply a force such a way that it makes make it to rotate the object or the body, that is called moment. Okay, and after application of this, okay, the algebraic sum of those forces or the moment. Why it is algebraic sum? Because some forces might be positive, some forces might be negative. So uh, so it is said algebraic sum. Okay, we want its algebraic sum, we don't want its arithmetic sum. So because there is a different sign conventions, plus or minus, so we want to have a algebraic summations. Okay, after applying those after doing those summations, if we get the forces equal to 0 and moments equal to 0, okay, then it is called as the body is in the equilibrium condition. If we do the algebraic summation of these forces and as well as the moment, okay, separately, okay, and we get the force is equal to 0 and summation of force is equal to 0 and summation of moments is equal to 0, then it is called as that the object is in equilibrium. Okay, this is how we can bring the object into equilibrium conditions by uh, making the forces and moments equal to 0. Okay, okay, so we will end here today and we'll continue the next into the next part. Okay.